Hello, and welcome back to this amazing channel. This is Abhinav. Today, in this particular video, we are back with our next Leetcode contest discussion, which is bi-weekly contest 136. Yes, and we will discuss all the four problems for this particular contest, which is for 1, 2, 3, 4, all the four problems, right? If I will say this contest was little on the observation level, right? Mostly the problems were observation based problem. There was no as such algorithms in there, no binary search, no other algorithms. It was simple, a logical contest. It was, right, and all the four problems were little on that level only. That was the contest, but I actually loved the problems of this contest. They were actually, I will say, a good contest, a tough contest. The third and fourth problems were of really good level, right? So let's start the discussion of the contest one by one. Uh, so if you will see, these are the four questions. Find the number of winning players. Then we have a minimum number of flips to perform to make binary grid palindrome. So the first version and the second version, both the versions are there. And finally, we have the third problem, which is time taken to mark all the nodes. This is actually a really amazing problem. So please wait for this problem. We will discuss it in a very amazing way, a very great logic. Okay, amazing. Let's start. So the very first thing is that they are saying in the very first problem, they are saying that find the number of winning players. Okay, so they are saying that basically we are having some 2D array pick that contains two things, xi and yi. That represents the xi player picked a ball of color yi. Okay, that is what they are saying. Now what they are saying, we have to find some number of players. Who player we have to find? We have to find those number of player where if player I wins the game, and if they pick strictly more than I balls of the same color. So a player I will win the game if he or she will pick same color ball for more than I time. So let's say I am player number 2 and I have some same color ball for more than 2 times. That means I am the winner. I will win the game. And here I have to find a total number of players who win the game. And there can be multiple players also, right? There was a basic thing. For every player, I will find the frequency of all the balls picked by that player. And if n and the frequency of any ball increases I, then I will simply say that that particular player is a winner. So let me see what I'm doing. I'm first of all going through all the players. Okay, so what I'm doing, I am iterating through all the players. That is the first thing we are doing. Okay, after that, what I'm doing, after that, for every player, let's say that currently we're at the player number I. We're currently at the player number I. So I will see all the balls which are picked by the player number I. Okay, so for example, I will first go through all these pairs of that pick array. And if there is a ball that is picked by player I, that is picked by player, means the ball, if pick J0 is 1, that means that ball is picked by player number I. So I will increase the value of that particular color for that particular player. Every player has its own map. And if for any particular color of the ball, the frequency increases I, that means that player is a winner, and I will increase the count of answer and I will break. Because for the same player, you should not count again and again. You will break the loop for that particular player and you will go to the next player, right? And then finally you will return your answer. So this is how I have done this. It's a basic brute force question only, a brute force approach only that we did, right? I hope that you have got the understanding of this particular problem. Okay, amazing. So now let's discuss the next problem. So this is the second problem of this contest, and we have the another version of this problem also, which is the third problem. We will discuss both of them. Actually, the logic of both are little different, so I'm not discussing both as a single one. This is actually a little of a different logical problem. Let me tell you what the problem is. Problem says that minimum number of flips to make a binary grid palindromic. Okay, that's the problem. So basically, what the problem says that you're having a binary grid. Binary grid means it contains 0 or 1. That is what the binary grid is. Okay. What you do is you have to make its row or column palindrome, not both. Either you have to make it all the row palindrome, or either you have to make it all the columns palindrome. That is the problem. या तो सारी रो palindrome हो जाए या फिर सारे columns palindrome हो जाए. That is what they are asking you. Okay, amazing. Now For example, you can see here in this case, they are trying to make all the rows palindrome. So to make all the rows palindrome, they changes these things to this. Even here, all the columns are also palindrome by chance. ठीक है? तो हम कैसे करेंगे इस प्रॉब्लम को? देखो, problem is very basic. First, you will see that if you will make all the rows palindrome, then how many number of operations are required? Then you will see if you will make all the columns palindrome, then how many number of operations are required. That's the basic agenda how we can solve this particular problem. Let me give you a dry run. Let me give you how we have done it. Okay. So, for example, let me first take a grid. A good grid I will take. Okay. So that we can have a considering of all the test cases. Okay. Actually, guys, second problem is really great. Second problem is really great how we have solved it. So do watch that also. Even if you feel it's a very hard one, please do watch it. Okay, please do watch it. I will recommend. So it's like this. Like this. Okay. For example, the values are like this. ठीक है. अब what I will do in this question, they are asking us either make all the rows palindrome or make all the columns palindrome, right? So let's see if I will make all the columns palindrome, then what will happen. So this is the first column. Let's say for rows. Okay, this is the first row. अब देखो ये रो palindrome है कि नहीं कैसे चेक करेंगे. So I will compare the first value with the last. Okay, then second value with the last second, third value with the last third, and so on. If I will say more specifically, अगर let's say if we have m columns, and we have n rows actually, अगर हमारे पास m columns हैं और n rows हैं, तो specifically if we will say, it will be that if we are currently at the ith column of a particular row, so ith column should match with the m minus I minus 1th column. And if they are not matching, that means we have to make a flip to match them. Let me give you example. For example, ये दोनों column match होने चाहिए. ये ith है which is 0. This is m minus I minus 1 which is actually 6. Right? Just like हम check करते हैं पहले, right? If they are not matching, then what to do? Then match them. Up for matching, either make 0 to 1 or make 1 to 0. Let's say we are making this 0 to 1. Up, are they matching? No. Okay, let's change it. Are they matching? No. Let's change it. Middle is always there. Now let's do the same thing for everyone. Okay, are they matching? No. Okay, are they matching? No. Are they matching? Yes. So if they're matching, don't do any change. So this is how one by one for all the rows I will find and I will count. If I will make all the rows palindrome, then what is the total number of operations, right? That is what happens for the rows. Now let's check for the column. That if you will try to make all the columns palindrome, तब क्या होगा? अब देखो, when you're checking for all the columns one by one, for example, that let's say you're first checking for this first column, say zeroed column. Okay, for that same thing. If you are in the first column, so the ith row should actually match with the n minus I minus 1th row. जैसे ये वाला इससे match होना चाहिए. This should match with this with this, and so on. जैसे ये match कर रहा नहीं कर रहा है, do one operation, change it. Is this matching? No. Do operation, change it, and so on. So this is how for every column also you will check. And finally, whichever is smaller, if number of rows are smaller or if number of columns are smaller, whichever is smaller, just take the minimum and return the answer. This is what we will do here. Okay, so if you will see my code, what I did, first I am checking for the rows. So I am first going through all the rows. Now for every row I am checking if its jth column is actually equal to its what m minus j minus 1th column. तो अगर ऐसा है, अगर jth column m minus 1 के equal है तो ठीक है, then it's fine. But if it is not equal, that means we have to make one flip, either there, doesn't matter, but we have to make one flip. One flip means that one operation will be increased. And this we check for all the rows, all the columns, right? And here we are going through all the columns and then checking there all the rows, that if the ith row, if the ith row matches with the n minus I minus 1th row. That's the basic thing. If this not matches, increase the number of operations. And then finally, whichever is having minimum number of operations, rows or column, whichever is minimum, that will be your answer, right? So this is how we are solving this particular problem. If we talk about a time and space complexity, guys, so for the previous problem also, by the way, for the previous problem, it was a very brute force problem. So it was, I think, around n into m time complexity, where n was the number of players in the previous problem. I am saying the problem number one, and m was the number of, I can say, the picks वाला array जो था वो, ठीक है. But if we talk about this problem is also order of n into m only, where n is the number of rows and m is the number of columns. Here also it's the same. ठीक है, अब देखो, ठीक है. This is how we are doing this particular problem number 2. Now the main thing is how we can solve the problem number 3, which is the upgradation of this particular problem. Let me tell you. Okay. So this is the problem. Minimum number of flips to make binary grid palindrome 2. Okay, how we will solve it? Very amazing logic, very amazing problem. Let me tell you. Here the problem is saying that you don't have to make either row or either column palindromic. No. Previous problem was that we have to make either all the rows palindromic or either all the columns palindromic. Here we have to make both. We have to make all the rows also palindromic and all the columns also palindromic. Yes, we have to make all the rows also palindromic and all the columns also palindromic. But how? Kaise? Let me tell you. And okay, one more concern is there. This was even easy. When I will show you the solution now, this was even easy to make all the rows and column palindromic. But they have added one more constant that you can see here. You have to find minimum number of cells to flip to make all the rows and columns palindromic, and the extra constant is they are saying the total number of ones should also be divisible by 4, means total number of ones should be a multiple of 4. That is what they are saying. Now let me tell you how we can solve this particular problem. Okay, just give me 1 minute, a water break. बढ़िया, great. Okay, so let me tell you the logic. कि logic क्या है? How we can make all the rows and all the columns palindromic. Okay, let me give you one example. ठीक है. So first of all, here also I will take a, so basically here I have to take multiple examples. Okay, so first I will take an example which will have same number of rows and same number of columns. So I'm taking a type of a square grid I'm taking. ठीक है. So I want the same number of actually rows and column here. So how many rows are there? So 6 rows are there, and columns are also now 6. So what I will do, I will make here like this. अब देखो, understand very carefully, okay, what we are doing. See, for example, guys, so see, the thing is we have to make all the rows palindromic and all the columns palindromic. let me give you first fun fact about it. So what we do, we have to make all the rows palindromic, all the columns also palindromic, and number of ones should be a multiple of 4. Okay, this is what the problem is. Ab how we can do this? How we can solve this particular problem? That's the important thing. How we can solve it? See, what we can actually do is, I will put here, let's say, see guys, for example, if there is a 1, let's say, if there is a 1, if there is a 1 here, that means that 1 should also be present here. Why? Because column should be palindromic. तो अगर एक 1 यहाँ पर है, इसका मतलब यहाँ पर भी 1 होना चाहिए. That means here also there should be a 1, and that means here also there should be a 1. So if there is a 1 at any index, all the 4 opposite index, it can be row wise opposite, column wise opposite, or diagonally opposite. At the same distance, there should be again a 1. And if there is a 0, यहाँ सब भी 0 होना चाहिए. Right. If I will say more specifically, so if you are currently at index number I comma j, then at index number I comma m minus j minus 1, at index number n minus I minus 1 comma j, and at index number n minus I minus 1 comma j m minus j minus 1, इन सारे ही इंडेक्स पे वैल्यू सेम होनी चाहिए. इन ऑल दीज 4 इंडेक्सेस वैल्यू शुड बी सेम if you want your grid to be palindrome, both row and column wise. For example, if I will make a 1 here, then 1 should also be here, here, and here. If I made a 1 here, it should be also here, here, here. If I made a 1 here, it should be here, 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 and here. You can see these are its palindromic opposite locations. These are its palindromic opposite locations. Are you getting or not? And this thing we will only check for until n by 2 columns and m by 2. Let me give you example. If I will take a very random grid, okay, a very random grid I am taking. Oh, what I am doing. तो हम क्या करेंगे, we will start from 0,0, and when I will check for an index I comma j, I will also check for these 3 indexes, because their all values should be same. अब वो वैल्यू में क्या बनानी है, that depends on क्या कितनी बार. Let me give you example. For example, you can see we are currently here. Now its palindromic opposite positions are this, this, and this. If you want, you can check using this formula. यही निकलेगा. So its palindromic opposite positions are this, right? Now you will see how many ones are there and how many zeros are there. So you can see there are 3 ones and 1 0. So which is better? तो better है कि आप सबको 1 कर लो. तो minimum of this will be the number of flips required. तो यहाँ पे हमें सिर्फ एक flip required होगा because एक ही 0 है. So we will make it 1. Now let's check for this. So you can see when I check this, and they are also considered. ये सभी consider हो गए. Now when I will check for this, so let's have a circle. We consider this all, let's say, and after considering this all, I will make it 1. Okay, amazing. Now let's consider this all. Now you can see this all are 1. No problem. Move on. Let's consider this all. Here 3 1, only 1 0 means make that 0 to 1. You will not make it. You will see okay, number of operations 1 होंगे. बनाने की जरूरत नहीं है. Now let's check for this. तो हम तो I comma j पे भी होंगे. We will be at I comma j only, but we will see कि अच्छा अगर we are at I comma j, its palindromic opposite positions are this, and this. We will check them. यहाँ पे आप देखो, there are 3 zeros and 1 1. So it will be better to make this 1 to 0. So whichever will be minimum. If number of zeros are minimum, take that. If number of ones are minimum, take that. Now this. यहाँ भी make it 0. Now this. Okay, I think I made some mistake. Wait, I made some mistake. Yeah, I made some mistake. So for this, it should be this and this. This will become 1. I made some mistake, sorry. This. Ab dekho, ones are also 2, zeros are also 2. Convert anything. Functions will be 2 only. This. Make it 0. This. Make it 1. This. Make it 1. This. Already 0. This. Make it 0. This. Make it 1. So after doing this, you will see that your number of ones will also be multiple of 4. Why? Why they will multiple of 4? Because either we are making all these 4 or either we are making all these 0. तो जो आपके नंबर ऑफ 1 है वो हमेशा मल्टीपल ऑफ 4 होंगे. There will be always multiple of 4. Okay, so what we are doing, and you can see I have to just iterate till here. If you will iterate just up to n by 2th row and up to m by 2th column, उतना ही iterate करने से बाकी सब ऑटोमेटिकली कवर हो जाएंगे, बिकॉज वी आर कवरिंग ना these 4 indexes. So if you will just iterate up to m by 2 row and n by 2 column, remaining will be automatically covered. I hope that you've got this from this here, right? So what I'm doing here is I'm first making my row up to n by 2th row and m by 2th column, and for every I and j I'm not just adding I and j, I'm also checking for n minus I minus 1 comma j, n minus I minus 1, m minus j minus 1, and I comma m minus j minus 1, which are these 4 indexes, right? And then whichever is the minimum of x comma 4 minus x, अगर 0 आता है या फिर 1 जाना है, जो भी आता है, जो भी कम है, sorry, that is the number of flips required. Whichever is minimum, number of zeros or number of 1, that will be the number of flips required, and that will be inserted in the answer. But this is not the complete, guys. Problem will come if number of rows are odd or the number of columns are odd. Here the problem will come. Let me show you why. Because let's take from this example only. I will do everything back. I will go back. Okay, I will go back and I will check one thing. Let's say, for example, this is not there. For example, when this is not there, what happened is you can see number of columns are just 5. Okay, अब देखो से problem क्या है. When you will consider this, these 4 will be considered. Okay, when you will take this, these 4 will be taken. Okay, here these 4 will be taken, क्योंकि यहां तक जाएगा ही नहीं. It is just going up to less than m by 2. You can see here. So it will not even considered for this, because इसके लिए there is no palindromic opposite. This is the middle element, right? Then same for this. The middle row, this middle column, sorry, because column are odd na, this middle column will be remaining. So this middle column we will apply a different approach what we did in case of previous. क्या previous? जो हमने पिछले क्वेश्चन में की थी. Same approach I will apply in this single column. So you can see I am saying that if your, so this is row odd, वो मैं बाद में बताऊंगा. If your column is odd, then what I am doing is, that I am doing the same. I am checking for all the rows of this particular column. If the jth row is not equal to n minus j minus 1th row, अगर वो equal नहीं है, that means I will make them equal and I will increase my answer. For example, जैसे कि this and this are equal, these two are equal, not a problem. These two are also equal, by the way, not a problem. Let's say कि यहाँ पर 0 होता, for example, that means these two are not equal. If these two are not equal, what you will do? So what I will do, I will not make my 0 to 1. I will always make my 1 to 0. Because I want multiple of ones, right? And already हमारे पास multiple of ones हैं. Because इस वाले operation में हमने या तो सारे 1 के होंगे या सारे 0 के होंगे. We know that in this operation we either made all the ones to 1 or we make either all the 4 to 0. So we already have multiple of ones. Now I don't want to break that thing. I will always, whenever there is a not equal case comes, I will always make my 1 to 0 so that the number of ones are balanced. Here also I will make my 1 to 0. Now this became palindrome. This became palindrome. अब there is a problem that occurs. Problem क्या है? Problem है कि for example कि you will see there कि okay यहाँ पर तो it was equal already 0 0 fine. यहाँ पे it was not equal, you will make this to 0 fine. But here they were already 2 ones. तो अगर जो 2 के पेयर है ना which are equal already, you will not change them. So if there are some pairs which are equal, let's say that the jth here the jth row is equal to the n minus j minus 1 column. जैसे यहाँ पर है दोनों equal है. Let's say they are equal. If they are equal and also they are 1, that means हमारे पास एक पेयर मिला 1 का. That means we got a pair of 1. We should not have a pair of 1. Either we should have 2 pairs of 1 because we want ones in multiple of 4. So whenever I will get a pair of 1, I will increase my count. And this is not just for middle column. It can also be a middle row. Let me give you an example. अगर ऐसा case होगा, if the case is like this, when we have number of rows also odd, let's say. तो यहाँ पर क्या होगा कि okay, these things are covered. Okay, this is covered, then this is covered, then this is covered, this is covered. But this middle row and middle column is a problem. Okay, तो इसमें क्या होगा कि it's fine. Whenever there is a non-equal thing, let's say 0 1, whenever we got a 0 1, I will make my 1 to 0 and I will make it palindrome. यहाँ पे 0 1 है, okay, make it palindrome. But when there is a 1 1, pair of 1 is there in both row and column. Row में भी if there is a pair which is equal and which is 1, I am increasing C. C क्या है? C is pair of ones which are equal also. And count is basically this. I will tell you why I am taking count. Count is number of flips we are doing. So whenever there is a non-equal pair, I will increase my answer, but I am also increasing my count. What is the reason of increasing count? Because we need it there. अब देखो problem क्या है? We need this pair of ones odd. क्योंकि अगर odd pair होंगे ना ones के, तो automatically it will be a multiple of 4. But if we don't have odd pair, let me give you example. For example, that here we have 1 and 1. Let's say. So if we have 1 and 1 here, even if I will make it 0, we have 6 ones. 1, 2, 3, 4, 5, 6. You will say, Abhinav, answer is not possible. Still answer will be possible. How? If we can make this 0 to 1. If we can make this 0 to 1, answer will be possible. Right? तो हम क्या करेंगे? तो देखो अगर if number of ones are odd, even if the number of pairs of ones are odd, but if the count is greater than 0, but अगर कहीं ना कहीं हम लोग switch कर रहे हैं, flip कर रहे हैं, if count is 0, then we can easily make the flip. But let's say even if we are not flipping, let's say कि ये already palindrome था, this was already palindrome, this was already palindrome. But problem is that it contains not a multiple of 4 ones. Then we have to actually flip some ones to 0, which need 2 operation, which I am adding here too. And finally, one last corner case, which is that if in the middle we have 0, then it's fine. कभी कभी क्या होगा, middle में 1 हो सकता है. Let's say in this middle there is a 1, and middle we don't check. In our palindrome also we don't check the middle, right? अगर middle में 1 है, if the grid of n by 2 and m by 2 is 1, then again increase the answer plus, and then because we have to make it 0. If it is a 1, make it 0. And then finally return the answer. So guys, this was a completely observation based problem. I actually tried my best to explain my logic to you, how I solved it. I know it's little typical. If you have a better solution, then also do let me know. But this is how I was able to solve it. Okay. The time complexity here also is n into m only. The time complexity n into m only. There is no actual space complexity. We have not used any extra space. It was a pure observation based problem, and I hope that you have got understanding. Still, if you have any doubt, please ask that to me in the Telegram channel, or you can also comment down your doubt. Okay, great. So now the last problem, which is time taken to mark all nodes. This is actually a problem of DP on trees, right? And let's see that how we have solved this particular problem. Actually, I was not able to solve this problem at the time of contest, but I was very close, very, very close. And after I think 10-15 minutes after the contest, I solved it, right? Because the first three problems I solved in just half an hour, right? आधे घंटे में solve हो गई थी. And then I was trying this problem for 1 hour, the whole 1 hour. But actually, there was like just one thing I missed, and because of that, I was not able to solve it. And then just 10-15 minutes after the contest, I solved it, right? This is the thing. Let's see what the problem is. Let's discuss that. Problem says that there exists an undirected tree with n nodes and with some edges. Obviously, if it is a tree, there will be n minus 1 edges, okay? And you are given the edges. There's an edge between u to v, right? Now what they are saying is that if the node I is odd, then then you will reach that node at time x if you have reached the adjacent node at time x minus 1, or we can say in more specifically, to reach this node it will need 1 second more specifically. And same if the node is even, to reach there it will take 2 seconds. Okay? Now what you do is you have to say that if you will start from a node I, then how much minimum time will be required, or basically how much time will be required to reach all the nodes if you will start from the node I. Okay. And this you have to tell for all the nodes, not for a specific ith node. You have to tell for all the nodes this particular thing. Okay, let me give you an example. Let's take a better one. See the example later. Okay. So this is the example. Let's say this is a tree that is given to us. Okay, why it's not loading? And this is the case. And so this is the edges given to us. We have 5 nodes here, right? More than the edges. So if edges are 4, there will be 5 nodes. That's the main thing, right? Okay, yeah, we got it. Okay, so see guys, what we are doing here. For every node we have to see. So for example, see, let's say that first we are starting from the node number 0. So actually I have to store in the answer array. I will show you how the answer is coming. Then I will show you the logic also. It was actually a very good problem, very good problem. What I can say, if someone wants to learn DP on trees and all, this is a good problem for that, right? So देखो, अब for example this is 0. अब you have to find starting from 0 what is the time required to reach all the nodes. ठीक है, अब देखो 0 से यहाँ जाने में कितना टाइम लगेगा? Just 1 second will be required. So here time is 0. You are starting from 0, so time is 0. Okay. Now to reach here, you will need time 1 because it's an odd number. So if it's an odd number, you will just need time 1. Okay. Now to reach here, you need time 2. Why 2? Because it's an even number. Now to reach here, you need time 1 more because it's an odd. So 2 plus 1, 3. And to reach here, you need time 4. So actually, if you're starting from 0, in how much time you can reach all the nodes? So you can see the maximum time you're getting is to reach this node, which is 4. So means in time 4, you can reach all the nodes. So for 0, answer will be 4. You can see here. Right. Same. Let's do for the other nodes also. Let's say you're starting from 1. Now if you're starting from 1, here it will be 0. To reach here, it will be 2 because it's an even number. To reach here, it will be 4. It will be 4. Here, it will be 6. And here, it will be 5. So maximum will be 6. देखो यहाँ क्यों 4 because it's an even number. So 2 plus 2 4. Again even 4 plus 2 6. So for 1 it will be 6. Right. Now let's start from 2. So 2 से start. So if you start from 2 to reach here, it will be just 3. Reach here it will be 4. Reach here again it will be 4. 2 plus 2 4. And here it will be 5. 4 plus 1 5. So for 2 it will be 5. You can see. Oh. Okay, for 2 it is 3. For 2 it is 3. Okay, sorry. We're starting from 2 now. Sorry. We're starting from 2, right? So here it should be 0. Here it should be 0. So here it should be 2. Here it should be 1. Here it should be 2. Here it should be 3. 2 plus 1 3. So for 2 it will be 3. Sorry, yeah. it will be 3. Right. Now for 3, what will be happen? So for 3 it will be 0. Here it will be 2 because 2 is a even. Here it will be again 4. 2 plus 2, 4. Here again 4, and here it's 5. So it will be 5. Okay. And for 4, let's check for 4. So for 4 it will be 0. This it will be 2. This it will be again 3. This will be again 4, and this will be 5. So for 4 also it's 5. So you can see the answer is 4, 6, 3, 5, 5. So this I am just trying to first explain you guys the problem, because even some function, some people can feel that the problem is not there, right? So I think, okay. So now I hope that you have got the problem statement completely. Okay. अब देखते हैं solve कैसे करना है. Now see how we will solve it. Okay. See, देखो, what we will do actually. What we will actually do here. देखो guys. So ultimately what we have to find. Ultimately we have to find it starting from a particular node. What's the maximum time needed to reach all the nodes? ठीक है. अब देखो guys. From every node we have 3 ways to go. For example, this is the first node. We have 3 ways. Either I can go to its left child. Obviously, if it is present. Either I will go to its right child. Or either go to its parent. हमारे पास 3 तरीके हैं, right? That from this 2, I will start. And I will go to the right child, the left child, and the parent. Okay. And I will mark it. So I will start from a node I. I will go to its left child, right child, and parent, and I will keep marking it. And whichever will take the more time will be my answer. जो भी ज़्यादा टाइम लेगा वो हमारा आंसर हो जाएगा. Yes or no? Whichever will take the more time will be my answer. So first thing what I will do, that for every node, I will find that how much time or how much maximum time is taken by its left child and how much maximum time is taken by its right child to actually reach its end. First, I will find this thing for the childs. And for doing this, what I did, now let me come on the implementation part also. Let me go on an implementation part. So, what I for every node, I have to see how much time its left child is taking, how much time its right child is taking, and how much time its parent is taking. And then whichever is the maximum time will be my answer for that particular node, right? Up now, first we will find for every node how much time its left and right child is taking. Let's see that. कैसे निकालेंगे मैं आपको बताता हूँ. What we will do actually is हम क्या करेंगे. First of all, I have taken 3 different vectors. First is a answer vector where I will simply store the answer. Okay. In this case, you can assume. Okay, I think my video is getting freezed because of a very because of the CPU uses, I guess. There's a very huge CPU uses in my MacBook. I'm not sure why. Maybe because this tab is open. I will close it maybe. Yeah. I hope that my CPU usage is fine now. Yeah, it's actually 24%. I'm not sure why. Okay, no worries. Maybe there is some lag in my video, but audio will be clear. Audio में भी कोई problem नहीं होगी, ठीक है? Amazing. Now see. So this is my answer array. You can see for a number of nodes I have created. Number of nodes are 5. Okay, this is my answer array. Second thing is that I will create my first array, which is my DP array. And what DP array is told? DP array is told that for every node, what is the maximum distance by its left and right side. So जो ही maximum है वो DP array में store है. So you can see I am creating DP array of size n into 2 because for every root its left side and right side दोनों का store करेंगे और जो maximum होगा वो पहले रखेंगे, right? So what I will do, I will create one more array which will be a 2D array of DP. 0, 1, 2, 3. I think एक से ज़्यादा बन गया. So 0, 1, 2, 3, 4. This is not required. Okay. And I will also divide it. This is a DP array. Okay. DP array 0, 1. I will store the maximum distance of its left and right cell to reach the end. Initially, everything will be 0. Answer will also be 0. This will also be 0. and one a simple adjacency list. I hope that you guys know how to build adjacency list. So for this particular graph, I will build its adjacency list. For example, if I will build here, I will say that the adjacent, so this I will little above, yeah, I will say the adjacent of 0 will be 1 comma 2, the adjacent of 1 will be 0, the adjacent of 2 will be 0 comma 3 comma 4, the adjacent of 3 will be 2, and the adjacent of 4 will be 2, right? This is how we will have. अब देखो हम क्या करेंगे. First of all, what I did, first of all, as I said, that for every root, for its child, we have to find the maximum distance to reach the end. कि उसके चाइल्ड में कितना टाइम लग रहा है नीचे पहुंचने में. कैसे निकालेंगे? तो यू कैन सी, first I made this recursion call. It's a simple DFS recursion call where these are the three things I'm passing, which is the answer array. So actually answer array is not required here. I think I passed, but it is not required here. So what I will do, I will remove it. It is not required, right? There's no need to take it. Remove it, okay? So there are two things I am taking here. First, it's the adjacency list, and second is this DP array, or I will make it as a child array. I use this DP. Better word will be child. It's fine, okay? तो क्या करेंगे हम लोग यहाँ पर? What I will do, I will initially pass my 0 and -1. So what is 0 and -1? First, I have to pass my current node where we are, and I have to also give my previous node. क्योंकि हमें दोबारा previous check नहीं करना. I have to check for the child. I do not have to check for the parent. We can make it as a parent also instead of previous. Parent बोल सकते हैं, right? So what I'm saying, initially I will call this DFS function for the root 0 and parent as -1. You can start from any. It's not a guarantee that always the root will be 0. You can start from any of the node. Not a problem, right? तो मैं क्या कर रहा हूँ? I will start from here. Right? I will start from here. Okay. Now when I start from here, what I will do, I have to find what is the distance by its left side and its right side. So first of all, I will go through all of its adjacent nodes, means its child, which is not its parent. तो इसका तो parent वैसे कोई भी नहीं है. So what I will do, for a particular node, for a particular root node, I am first of all going through all the adjacent roots, or we can say all the childs. I will go through all the childs of a particular node. Obviously, in the adjacent root of a particular node, its parent can also be there. So if parent come, skip it. If it's not a parent, means if it is a child, then find the distance taken by that child. So now what I will do, I will make the recursion call for that child, for that j. For example, first I made the call, let's say for this one. I made the DFS call for this one. When I made a DFS call for this one, it will make the DFS call for its child, first child. अब when this DFS call will go, अब देखो इसका कोई भी child नहीं. This does not have any of the child. It has one adjacent node, but it's a parent, right? So I will make the adjacent call for this j, which is actually 1 in this case. What will actually happen is कि it will not have any other call because it has no adjacent child. It has one adjacent node which is a parent, right? तो कोई call नहीं होगी. And if there will be no call, इस one के लिए its DP will be 0 and 0. क्योंकि इसका there is a 0 distance required to reach the end. वो खुद end है. So there is no more distance required. Okay. अब क्या होगा? We know कि for this 0, इसका ये child है. For it, the maximum distance required is 0. But to reach that कितना required है? So to reach that required is 1. Why 1? Because it is a even number. It is a odd number. So I will see. I will first get the distance for this jth node, which is already stored in this DP. क्योंकि जब recursion call जाएगा तो DP में store हो जाएगा. और अगर if there is no adjacent, DP is already 0,0, right? तो for this one, उसके लिए maximum कितना है? 0. So that 0 will come. Plus, if that j is even, that j is odd, then 1. Else 2. अगर j odd है तो 1. अगर j even है तो 2. That will be added. This current is actually the value of its to reach the child. तो मतलब इस 0 के लिए, if you will go this side, this much is the amount of time which is needed. Are you getting? For this node 0, if you will go towards this child, this is the current amount of time which is needed. कैसे? First, I will get that for the child, what's the amount of time taken, plus time taken to reach that child, right? And then finally, as I told you, we have to store that maximum amount in the DP. So now, अगर ये current DP of root 0 से भी बड़ा है, then make your DP of root 0 equal to current and DP of root 1 equal to DP of root 0. बेसिकली हम लोग मैक्सिमम एंड सेकंड मैक्सिमम स्टोर कर रहे हैं लेफ्ट और राइट चाइल्ड के लिए. ऐसा क्यों बताता हूँ, सिर्फ मैक्सिमम क्यों नहीं कर रहे हैं, वाई वी आर नॉट जस्ट स्टोरिंग ओनली मैक्सिमम, आई विल टेल यू. ओके, दिस इज आई विल डू. तो आई विल डू दिस फॉर एवरीवन. तो फॉर एग्जांपल फॉर दिस 0, इट विल जस्ट चेक फॉर दिस. So for this, it will say, okay, distance required is 1. So 1 will come here, 0 will come here. For this 0. Now it will call for 2. 2 will call for 3. So for 3, it will be again 0 and 0. Because 3 does not have any child. For 4, it will be again 0 and 0. But, for 2, यहाँ पर आके distance is just 1 because it's a odd. Here it is 2. So ultimately for 2, maximum distance is 2 and second maximum is 1. अब देखो, for this 0, here it was 1, here it is 2 plus 2 4 because यहाँ से 2 आया, right? इसका maximum 2 रहा, plus 2 because this is also even, so it will be 4. So for 1 it will be actually 4 comma 1 because first maximum is storing in the 0 index and second maximum in the 1 index. यहाँ से 4, यहाँ से 1, right? Are you getting? This is how after this DFS call is completed, this will be the DP vector that we will get. Okay. This will be the DP vector that we will get. ये बन जाएगा हमारा. Makes sense, right? Makes sense. Now let's see how we'll use this DP vector. So what is this DP vector? This DP vector is actually showing the time taken by your current node to go in its both the child. For example, इस 2 के लिए अगर देखें तो कितना टाइम maximum time required होगा to reach its end. So for this 2, the maximum time required to reach its end through childs. Currently, we are not talking about the parent. No, we are not talking about the parent. We are talking about a child. So for a child, it will be 2. कैसे? ऐसे. For 0, it will be 4. How? Like this and this. But now we will not just check for the childs. We have to also check for the parent. So for that, I will make one more call. What is the one more call? Which is the next call, again similar to BFS, but here we are naming it as find maximum. अब देखो ये function क्या है. Now once this function is done, now I will call one more function which is exactly similar to that. The only difference is here, again, we have 0 current node, -1 parent node, and one more 0 is there, which is actually the time taken by its parent to reach the end and the other end. Let me tell you one thing. Okay, for example, we made a call for the root. हमने root के लिए call मार दी, ठीक है. For example, this is the root. अब for this root there is no incoming, मतलब there is no parent. तो कोई parent तो है नहीं इसका. तो for parent initially I will pass -1. There is no parent. Initially it will be 0 -1 whatever 0 we can say, right? तो initially your incoming is 0. तो इस root के लिए क्या हो जाएगा? इस root के लिए answer will be whatever is the maximum time taken by its child to reach. तो इस 0 के लिए maximum time taken will be 4. To answer for this 0, I will at the same time I will make it as 4. You can see I'm saying answer root is equal to max of incoming comma dp of 0, which is 4. क्योंकि इधर से इधर में maximum कितना है? Maximum is 4, which is told already here. Now main thing is when I will go for here. This is the main. जब हम इसके लिए आएंगे तो कैसे निकालें? See, when the call made for this, its child. So you can see when I'm making the call for the child. So for every root, what I'm doing, I'm iterating through its child. Up see guys. For child, it's very important because for this 2, we know कि लेफ्ट चाइल्ड में 1 लग रहा है, राइट चाइल्ड में 2 लग रहा है. वी नो कि मैक्सिमम इज 2, हमें पता है. बट ऊपर से कितना लग रहा है? मे बी ऊपर ज़्यादा लग रहा हो, मे बी फ्रॉम टॉप इट्स मोर. वी वांट द मैक्सिमम ना. अब हाउ वी कैन सी कि उसको पेरेंट के थ्रू कितना लग रहा है? हाउ वी कैन सी? तो व्हेन आई विल मेक कॉल फॉर दिस 2, आई विल ऑल्सो गिव द इनकमिंग कि पेरेंट की तरफ से कितना टाइम लग रहा है. आई हैव टू गिव इट. हाउ आई हैव टू गिव इट? फर्स्ट ऑफ ऑल व्हाट आई विल डू, आई विल गेट दिस 0. हम लोग यहाँ पर 0 में. अब लेट्स से आई गॉट द एडजेसेंट नोड 2. Okay, what I will do, I will first of all take my PA which is parent, कि parent की तरफ से कितना लगेगा. तो first of all, if parent is even, then, and if you will go from 2 to 0 means to the parent, and if parent is even, then automatically you will take 2 cost. If it is odd, you will automatically take 1, whatever is the parent. So I'm simply checking if my root is even, odd, take 1, else take 2 automatically. That if from that node you will go to parent, automatically your 1 or 2 will be added. वो ले लिया. But that is just here. ये तो सिर्फ इस parent का, यहाँ से यहाँ जाने का. What about this? What about this? अब देखो, we already know that for every root node उसका left child right child कितना है हमें पता है. But it can also be, but we can't say कि इधर वाला, कि हमें क्या करना है, when I have to give it here incoming, when I have to give incoming here, it should be 2 plus 1 3. तो ये तो 2 है, we know it is even, so PA will be 2. But how we will know that कि in this 2 this 1 will be added, not 4? Because जब हम लोग यहाँ के लिए निकालेंगे, because when you got for this 1, तो यहाँ पर it will be 2 plus 4, because 4 is required here and 2 here, so it will be 6 for this. But for this it will be 2 plus 1. So when that child node is on the left side, then your cost will be the root plus right. When it is on the right side, then your cost will be root plus left. Are you getting? How you will know that? So for knowing that, what I'm doing is that is why we have stored a second maximum. So first one, I'm going through all the adjacent node. If adjacent node is not a parent, तो आई विल सी द करंट वैल्यू. कि करंट वैल्यू क्या है, कि मतलब जो हमारा पेरेंट है ना, उसके लिए करंट रूट की वैल्यू क्या होगी. व्हाट विल बी द वैल्यू फॉर द करंट रूट, उस साइड वाले रूट. फॉर एग्जांपल, इफ फॉर दिस पर्टिकुलर चाइल्ड इसका पेरेंट क्या है, फॉर दिस पर्टिकुलर चाइल्ड व्हाट इट्स मैक्सिमम चाइल्ड इज, तो फॉर दिस 2 its maximum is 2, and because this 2 is even, one more 2 will be added, so basically 4. तो मतलब इस 1 को इस 0 को, this 0 is getting 4 from this side, this 0 is getting 4 from this side, and one of these values should obviously be 4, क्योंकि आपको 4 यहां से मिल रहा है. So if you're getting 4 from this side, then we will get to know कि उस साइड से क्या आ रहा होगा, what is coming from the opposite side. If we will know कि from this side what is going to the dp vector of this 0 index, then we can know कि from the opposite side what is getting, and that is what we want. So if dp of 0 is equal to current, that means on the other side dp of 1 is coming, but if else dp of 0 is coming. For example, यहाँ पर आप देखो, यहाँ से 4 आ रहा है, मतलब यहाँ से 1 आ रहा होगा, right? And then this one will be added in the PA, remember? So your maximum will be maximum of PA plus incoming, because देखो दो चीजें हैं, एक इधर से और एक इस PA का भी incoming होगा ना ऊपर से. For this PA maximum क्या होगा? For this PA there are 2 maximum, either from here, either from its top. So either PA plus incoming, either PA from its other side of the child, and then that will be the incoming for this P, and I will make the recursion call. Are you getting? So this is how we are solving this particular problem. I hope that you got understanding, and this again is a kind of a DFS, right? So I tried my best, guys, to explain you this thing. So basically यहाँ पे क्या होगा कि for this 2, for this, so let me tell you कि for this 0 we got, now I will make for this 1. For this 1, from here it will check, okay, this is PA is 2, it has no incoming, and from here it is having 4. So here it is coming 6, here it is coming 0, so maximum is 6. That is why answer here was 6. Right? Answer here was 6. Now for 2, how it will go? So for 2, what we will do? It is 2. From here maximum is coming 4. But from here, if you will see, it will say this is 2. In top is nothing. Here it is 1. So plus 1 is 3. Maximum is 4. Right? Maximum is 4. Oh, sorry, not maximum 4. Sorry. So for this 2, इसके लिए तो 2 और 1 है ना, तो यहाँ से 2 मिल रहा है, sorry. From here you are getting 2, and from here 1. So here maximum is 2. Here it's 2, 1, 3. So final answer is 3. So for this 2, it will be 3. It will be 3. Right. Now same for this 3. There is no child. Both are 0. it will just check the parent. For parent, there are two ways, either from here, either from here. Whichever is the maximum, you will go here. Because the parent is even, your PA will be 2, which we are checking here. Now check for that which side of the child should be taken. This side is already there, take from this side. So 2 ka 2 wala, because this is 1. If this is 1, that means 2 is the thing. तो यहां से 4, this is 4, and top से कितना? So from top, how much? Incoming was how much? Incoming was 3, and this is 2. So 3 plus 2, 5. 5 comma 4 ka maximum is 5, so final answer will be 5. And same for this 4 also. Very similar for this 4. From here, incoming 3 plus 2, 5. And from here it is 3 plus 2 plus 1, 3. Maximum is 5. So it's 5. Right? So guys, this is how we are actually solving this particular problem. I know it's a little complex one. It's a DP on trees, but yeah, it was having a very amazing, very good logic. So I hope that you have got an understanding of this particular video. It was a basic DFS solution. So time complex is order of V plus E only. It's a linear time complexity only. 2 times you are making DFS, so we can say 2 into V plus E, and that's it, right? 2 into V plus E, right? So guys, I hope that you've got the understanding of this particular, all the 4 problems of this particular contest. Still, if you have any doubt, do join our Telegram channel. Do comment on this particular video. Thank you. See you in the next video.